Hello. Today our topic is logarithms. Okay. So let me just write y equals to a power x. Okay. So this is an index form. Okay. And now I can write this as log base a of y equals to x. This is a log form. Okay. So, what is logarithms basically? So, logarithms is uh, to what exponent, like this is the exponent, to what exponent must we raise a certain base? So, a over here is a base to get a given number, and y over here is the given number. Okay, so basically a is the base, y is that given number, and when we resolve log, we are basically trying to find like to what extent do I raise a so that I am able to get y. Okay, so that's what you use logarithms for. Now, logarithms have certain rules. Okay, so rule number one, okay, that is that a should be greater than 0 and a cannot be equal to 1. Okay, so a should always be a positive value and a should not be equal to 1. Okay, why? Let's just try this out and we'll know. Okay, so let's say over here I basically try to put y equals to 1 power x. Now, no matter what value of x I put in, okay, I will always get the answer 1. Okay, and basically, so for one value of y, so like for infinite values of x, I'm just getting one single answer. So that's why we don't really use like equals to 1. So that's why a should not be equals to 1 and a should be positive. The another rule that we have over here is y should be greater than 0. So y should also be a positive value. Okay, because if you put y equals to 0, okay, so like let's say over here if I put y equals to 0 and a power x, okay, so basically no combination of this makes it 0. If I put a very small value of x, I might get closer to 0 but not 0. That's why we don't use it. Okay, so now there are a lot of also laws in logarithm. So let's start with the easy ones. Okay, so we have a zero law. Okay, zero law is so log base a of 1 is equals to 0. What this means is that so the what is my index form? Y equals to a power x. Now if I try to map this, so I have 1 equals to a power 0. So any number is raised to power 0 is equals to 1. Okay, so this is zero law. Now we have identity law. What is identity law? That if log a of a, that's equal to 1. Okay, let's also try to write this in index form. So if we map this, what this basically means is that a equals to a power x, okay? And whenever this is equal, so it will only happen when x is equals to 1, okay? That's why we have this identity law. Okay. Now, the next law is power law. So what is power law? That if, let's say, I have log a of y and y has a power m, okay, then I can write it as m. So I can bring this m basically down here and it will become m log a y. Okay, so also let's try this out. So for example, I take let's say so what do we have, like 2 power 3, let's say. So I have 2 power 3 which equals to 8. So this is an index form. Okay, now if I try to write this in a log form, so this will be log base, which is 2, of 8. Okay, so and like we know that we raise to the power 3, we get this 8. Okay, now what I can also do is I can write it as 2, and I know 2 power 3 is 8. Okay, I can bring this 3 over here, so I will have 3 log 2 of 2. And now what did we study here? Identity law, that this part will become 1. Okay, so what I'm left with, basically 3. Okay, so that's how we can also simplify our equations and write it as like this. So that's how power law is helpful. Okay, okay, so the next law is basically an interesting one, and this is change of base law. Okay, so let's say that I have x equals to log a y. Now I want to change this base. Like I don't want to solve it with a, I want to solve it some value b. Okay, so how do I basically change this equation that am able to bring log b over here? So I know the index form is y equals to ax, right? Now I apply log on both the sides. So if I apply, and now I can apply log whatever the base I want. So what I will do is log b of y equals to log b of ax. Okay, and using the power law, I can write this as x log b a. And now I can basically bring this down. So if I solve this out, what I'll be left with is log by over log ba. Okay, now if I compare this equation and this equation, so log ay is equal to log by over log ba. Okay, so this is how I am able to change the base of this log. That is why it's called change of base law. Okay, okay. Now, next, what we have is we have product law. Okay, so what this states is if I have log a x y, I can write this as log a x plus log a y. Okay, now let's try to test this out. Okay, so what I have an example, like let's say I have 5 power 5, and I know we can write this as 5 power 2 multiplied by 5 power 3. Okay, now if I apply log base 5 on both sides, so what I will have is log 5 of 5 power 5 equals to log 5, and I will have log 5 square multiplied by 5 cube. Okay, now using the product law, I can write this as log 5 square plus log 5 cube. And over here I will using the power law, I'll bring it over here. So what I'll be left with is 5 log 5 of 5. And using identity, I know this is equals to 1. Okay, so using power law, I can also bring this over here. I will bring this over here. I know log 5 of 5 is going to be 1. So what I'll be left with is 5. From here I will have 2, and from here I have 3. So this is the same on both the sides. So that's how we use product law. Now, the last that we have is quotient law. Okay, so what this states is log a x over y is basically equals to log a x minus log a y. Okay, also let's try the example of this. So let's say I have 5 square, which is equals to 5 power 5 over 5 power 3. Okay, and let's write this all in the log form. So what I will have is log 5 square equals to log 5, and I will have 5 over 5 over 3. Okay, now I can bring this over here, and identity law, I know this is equals to 1. So over here I have 2, and over here using the quotient law, I can write this as 5 log 5 power 5 minus log 5 power 3. Now using the power law and identity law, I will have 5 minus 3, and where I have 2. So basically this also is equal on both the sides. So let's just do a super quick recap. So what did we do? We saw what's an index form and how it looks in the log form. Okay, we have a base, we have a power, and we have the number that we get when we basically solve the base and power. Okay, we have two rules that a should be positive and a cannot be equal to 1. Another rule was y should be positive. Then we started with zero law. So zero law states that log base a of 1 is equals to 0. Okay, we saw an example of it, that y equals to a power x. Like if y is 1, it basically means that a is power 0. Okay, because anything power 0 is equals to 1. Then we had identity law that states that base and the number both are equal. So the power is going to be 1 because anything that has power 1 is itself its same. Then we started with power law that anything in the power, it basically becomes the coefficient. Okay, and that's how we resolve the power law. We saw an example, and that 2 cube is 8, and we write in log form. We know 8 is 2 cube. We brought the 3 to the coefficient, and we had log 2 of 2, and that's an ident, and using identity now we know that's 1, so we're left with 3. Then we did the change of base, where basically if you want to change the base a, so you can write it as log b of y over log b of a. Okay, so basically the number becomes, it comes in the numerator and the base comes in the denominator, and whatever log you want to use, you may use that. Then we have product law, that log a of x and y, xy will be can be written as log ax plus log a of y, and we saw an example of it. And after that, lastly, we saw log a x over y can be written as log a x minus log a y, and we saw an example of that too. Okay, so yes, commonly, so what we use is log base 2. These are commonly used. We use log base 10, and we also use log base e, which is also called ln. So these are called natural logs that we use in a lot of mathematical fields, or in physics, or in chemistry. Okay, so hope this was useful. So thank you so much.